This morning we will start with our notes on worksheet number 2. Right, so here's a warm-up. So I want you guys to try to solve for x and y from these two diagrams. I'll give you about a minute to work it out, and I'll go over the answer with you guys. Okay, so let's try this one first, right? So Sam, we see that these two have the same marking. That means that this is an angle bisector. So if this is 4x minus 5 degrees, this side is also 4x minus 5 degrees. So we can say that 4x minus 5 degree plus 4x minus 5 degree equal to 150. Right, so from there we can combine like terms. So this gives us ax minus 10 degree equal to 150 degree. And then from there we can solve x by adding 10 degree to both sides. So this gives us ax equal to 160 degree. So to solve x, we divide both sides by 8. So then x is equal to 160 degree divided by 8. So x is 20 degree. Right, and then for our next diagram is based on our vertical angles. So these two are vertical, so they are congruent, so they have the same measurement. So we can say 2x plus 5 equal to 3x minus 33. And then from there we can solve for x by minus 2x from the left, minus 2x, and then plus 33 and plus 33 degree. So this reduces to 0, so we have 38 degree equal to 1x. So the x is equal to 38 degree for this diagram. Now to solve for y, easier if I extend this line out, so then this form a linear pair. So linear pair means that the sum is 180 degree. Right, so we can say 2x plus 5 plus 4y minus 1 equal to 180 degree. But then we know that x is 38 degrees, so we can substitute this in for our x. So we say 2 times 38 degree plus 5 plus 4y minus 1 equal to 180 degree. And then now we need to combine like terms. So 2 times 38 plus 5 minus 1. So this gives us 80 degree plus 4y equal to 180. So to solve for, so we have 4y equal to 100 degree. When we work this out, so it gives us y is equal to 25 degree. Okay. Right. Our next example is based on the distance formula. So this is called our distance formula. So to make it more easy, to say that we have our segment point A and point B. So point A we call it the coordinate x1, y1, and point B we call it the coordinate x2, y2. So we want to find out what is the length between A and B. So we will use this formula. Right, so here is an example that we have a point. So we can call this point A and call this our point B. And we assign the coordinates for point A, x1, y1, the coordinates for point B, x2, y2. So the formula said that we take x2 minus x1, so we take 5 minus 2, the quantity square, plus negative 3 minus the negative 4 squared. So in double negative, this become a plus. Right, so 5 minus 2 gives us a 3. And negative 3 plus 4 gives us a 1 and square. So 3 squared gives us a 9. And 1 squared is 1. So then 9 plus 1 is 10. So the distance is equal to square root of 10. Okay. Now it's okay to leave it in terms of the square root of 10, right? So we call this our exact answers. Okay, so this is the same example. And then the other definition is called segment addition postulate. If a point B lies on a line segment AC, then the distance between AB plus the distance between BC is equal to the distance from A to C. Okay, so it's saying that if we take this part plus this part here is equal to the whole segment from A to C. Right, so for example, if I were to give you this is 3 and this is 5, so then the distance from A to C is 3 plus 5 over 8. Right, so let's go to our example 2. Find the length xy in the figure shown. Okay, so here we can say that xy plus yz equal to the distance from x to z. And we're solving for xy, so we leave it as xy. And yz is 11, so we write it as 11. And xz is 17, so we write that, solve for it. So then xy equal to 17 minus 11, which is 6. Right? Okay. And our next definition is called linear points. Say 2 points, or we can say that 2 or more. Right? So 2 or more points that lie on the same line. So here we can say that we can have a line, and we can have point A, point B, point C, point D, and so on. Right? So two or more points that lie on the same line is called collinear points. So the diagram below is that point A and point B are collinear because they are on the same line, and C is not because C is not on that line AB. Right, so that's the end of our notes for worksheet 2. So your assignment for tonight is on worksheet number 2.